So first, for the first question, which of the following industries are classified as secondary industries? So just here you should remember the definition of primary, secondary, and tertiary industries. You know that primary industries will deal, if you want, with is, is just the first stage of anything to do. And for example, agriculture, fishing, mining, all are primary industries. Secondary industries will transform the things provided from primary industries to transfer them into products that can be that are useful. Uh, so this is the secondary industries, and tertiary industries is the service sector. So here, for example, what are the secondary industries? Beverages. So is beverages a secondary industry? Yes, because I'm transforming primary material into a product that can be used. Okay, so the first answer here is this is a right answer. Second one of secondary industries is beverages. Financial services is in which type of industries is tertiary industries because it's a service sector. Okay, so it's not included in the secondary industry. Fishing, fishing is primary industry because it's in the first stage. Okay, we are just taking the natural product as they are without changing them. The same for mining. Mining is one of the primary industries. Now, power utilities, here we are coming up with new equipment to be used. So this part is secondary industries. Okay. And for publishing, we are transforming primary materials into books and journal papers. So this is also secondary industry. While the transportation is a service sector. Okay, so just you should know what is the definition of primary, secondary, tertiary to be able to answer this question. Now, second question, which one of the following engineering materials is defined as a compound containing metallic and non-metallic elements? So here you should know what is the definition of each type. Okay, if you go back to your course material, the material that is a compound of metallic and non-metallic element is ceramic. Okay, so this is the right answer. So this is the details. This is the type of details you are responsible for. Okay, and whenever they define several elements, you should know what is the difference between them. You have several categories, let's say, of the formation processes. You should know these categories. You should know, for example, what is the definition of primary, secondary, and tertiary industry, so that you can select, if I give you such question, the corresponding answer. Another question, which of the following processes start with a material that is a fluid or semi-fluid state and solidifies the material in a cavity? So this is from the last chapter, okay? We have seen together that the processes involving solidification, for example, it's not, of course, forging, turning, and pressing. All of these are just defined, and machining are defined in as an overall definition in the first chapter. So, and we have seen in the final chapters that we have casting and molding. These two will deal with solidification. هلا نحن we didn't go over the difference in between, okay, but I will just now explain it. هلا in the exam, of course, everything not explained will, this was not tackled yet because chapter 7, if you want, we have several parts that are not, it's not completed, and chapter 8 also is a continuity for chapter 7. So for this question, don't worry, and I don't expect that you know the difference between molding and casting now, but just if you want to know the difference, okay, in general, we refer to, when we talk about casting, we refer to die casting and injection molding. And in this case, we generally breaks down the material. Okay, so molding is for plastic, while casting is for metal. And the main difference is that molding is performed for plastic, while casting is for metal. And but this question, you will see it in future chapters. This is why, if you want, it's not you are not supposed to answer it now. But sometimes you can just, from common sense, you can answer. Okay, because we have already seen uh, the process. We have talked about casting, and we have talked about molds. So it can be familiar for you that casting and molding deals with solidification of material, while the other processes that we have seen them in summary in the first chapter are not dealing with are not solidification processes. For the first question, uh, which deformation processes include which of the following? So here, this is a part of the categories of processes. We have divided the processes into several categories, if you remember. Solidification processes, deformation processes, particulate processes, etc. So the deforming processes consist on taking a metal that will undergo a plastic deformation. And we have seen together that these processes involve extrusion and forging. So here the answer is extrusion and forging. Okay. For example, milling is one of turning operation, so it's something different. We have drilling is a removal process. Okay, so it's not in the section of the formation process. Now, the fifth question: in the periodic table, the elements can be divided into which of the following categories? If you remember, when we talked about the periodic table, we divided the elements into metallic, non-metallic, and semi-metals. So here, for example, of course, when you read the different possibilities, always in MCQ, read all possibilities because you might have several answers. Okay? So here in periodic table, of course, we are not dividing into ceramics, gases, liquids. Metals is one of the subdivisions, non-metals, and semi-metals. So this is the right answer here. Now, question 6. How many atoms are there in the face-centered cubic unit cell? So for the face-centered cubic unit cell, when we defined it, we said that for this configuration, we have atoms at the corners. Okay. How many corners I have in a cube? I have 8 corners. So already I have 8 atoms. Plus, since from its name, face-centered, I have at the center of each face, I have an atom. So I have 8 atoms at corners, and I have plus 6 atoms at center of faces. 6 atoms at center of faces. So I will end up with, in total, 14 atoms. So I will select the answer E. So I have 14 atoms in FCC configuration. Now, for question 7, which of the following are not point defects? So, for example, in the defects, we have characterized point defects, surface defects, okay? So you should know, if I ask you if this is a point defect or a surface defect, you should know. And you should know what are the different types of defects. So we know that if you remember, we divided the defects into several types. We have point defects, line defects, and surface defects. So here we want to select what are the defects that are not point defects. Okay. So first, edge dislocation is which type of defects? Who remember? Edge dislocation is which type of defect? Yes, exactly. It's a linear defect, so it's not a point defect. So I will select it. Grain boundaries is which type of defect? Exactly, it's a surface defect, so also it's not a point defect. I will select it. Now, interstitiality is a point defect. As a Scotty defect is also a point defect. A vacancy is also a point defect. Screw dislocation is a line defect. So also screw dislocation is not a point defect. So here I have three right answers. Now, question 8. Polymers are characterized by which of the following bonding types? So you should know the characteristics of polymers, the characteristics of ceramics, the characteristics of metals. So in the summary of in one of the chapters, we have summarized the characteristics of each type. We know that polymers in general do bonding types. Which are the main bonding types in polymers? They are related by covalent bonding and hydrogen bonding. Okay, so these are the types of bonds in polymers. Now, question 9. Which of the following is the correct definition of ultimate tensile strength as derived from the results of a tensile test on a metal specimen? So we know that the ultimate tensile strength is the maximum engineering strength. Okay. So first, they said it's the stress encountered when the stress strain curve transforms from elastic to plastic. No, this is the definition of yield strength. The maximum load divided by the final area of the specimen. No, because we know that the ultimate tensile strength is defined as engineering value, not as true value. The maximum load divided by the original area of the specimen. Yes, this is the right answer because the tensile strength is the engineering value of the maximum stress. So this is our answer here. It's answer C. Okay. And C, the stress observed when the specimen fails. Of course not, because at fracture, we have in a tensile test, we have the necking effect. So the stress will be reduced. Okay, now, question 10. Which of the following types of stress-strain relationships best describes the behavior of brittle materials such as ceramics and thermosetting plastics? If you remember, brittle materials are weak in tension. They cannot support, they cannot go to plastic deformation. So their behavior will be perfectly elastic. Okay, so when we define the behavior of brittle material, it's perfectly elastic because they will not yield. These types of materials will not yield. So the answer is perfectly plastic. Sorry, perfectly elastic. Now, question 11. Thermal energy is normally associated with which one of the following changes in the altered layer? We have seen that we have change in the altered layer and we can have changes in the surface. Okay, so for example here cracks is a change for the surface, not for the sublayer. Okay, hardness variation is one of the characteristics of how altering the sublayer. So this is one possibility. You have heat affected zone also. We have seen that this phenomena is, for example, in case of welding or in case of high cutting temperatures, we will create deformation. We will have a certain affected zone in the sublayer of the surface. So this is also a thermal energy that will alter. This is a result of thermal energies that will alter the sublayer. Now, plastic deformation, no, it's not. Plastic deformation is due to what? It's not due to thermal energy. It's due to what? Mechanical energy. Okay. Now recrystallization, yes, because the recrystallization process will affect the sublayer and is due to thermal energy. So these are the different types of that will result in changes in the altered layer by thermal energy. Now, in a casting, a flask is which of the following? It's the beverage bottle for foundry man. It's the box which holds the cup and drag. It's the container for holding liquid metal, or is the metal which extrudes between the mold halves. So here you just have to know what is the main rule of each part of my system. So if I have a casting process, we have described together the different we have described the different objects like the runner, the down screw, the gating system. So we should know what is the rule of each of them. So here we know by definition what is the flask. The flask is simply is the box that is containing, okay, the copandra. Okay, so this is the definition. So the right answer here for the flask is this one. Now, in question 13, in foundry work, a runner is which of the following? So also here we should know the definition of each part. Okay, we have that first, the runner is the channel in the mold leading from the down screw to the main mold cavity, or it is the foundry man who moves the molten metal to the mold, or is the vertical channel into which molten metal is poured into the mold. Which one is the runner? The vertical channel is called what? Yalla, who remember? Which answer is right here between A, B, and C? No one knows what is the true answer? Yes, exactly. It's part A because the vertical channel is the down screw. Okay, the runner is the channel that will lead from the down screw to the main mold cavity. So if you look at the figure, let's say you have here, you are pouring your material here. You have the down screw, which is the vertical channel, and then you have the runner, which is taking the metal or the molten metal from the down screw towards the cavity. So this is the cavity. So this is the runner. Okay. So here the true answer is part A. Now, the total solidification time is defined as which of the following? It is the time between pouring and complete solidification. It is the time between pouring and cooling to room temperature, or it is the time between solidification and cooling to room temperature, or the time to give up the heat of fusion. So if you remember from the cooling curve, okay, we have seen that we have first the pouring process. Once the pouring process is, يعني the pouring process at pouring temperature, once the pouring process is done, first we have a certain phase of cooling before reaching the solidification temperature, and then we have the change of phase until reaching complete solid. So the total solidification time will start after just when we finish pouring to complete solidification. So this is why here the answer is the time between pouring and complete solidification, because the total solidification is this total time. Okay, so this is the type of questions you are expected to have in the exam, and everything covered. And this is a sample of possible questions. All details similar to these you are responsible for. And you should read several times the slides to know these details. Okay, You should know the definition of, for example, you should know the difference between different types. Whenever we have categories, you should know what is the difference between them. For chapter 2, I gave you some problems. And I gave you problems on all chapters because as the ones we did together. Yani for chapter of ionic and covalent bonding and hydrogen bonding, I gave you maybe 2 questions on this. Yani to do small problems. You should know how to write the Lewis presentation of a covalent bond or of an ionic compound. You should know what type of bonding you will have between, if I give you two elements, you should know what is type of bonding and what is the resulting compound you have. This is for problems on chapter 2. For problems on chapter 3, we have solved a lot of things. So you should know how to find the modulus of elasticity. You should know how to find the strain hardening component and the exponent and the strength coefficient K and N, how to calculate them. You should know how to relate, how to calculate through engineering, through stress, engineering stress, through strain, engineering strain, how to determine the separation between flow curve and true curve, all of these details. You should, if you solve the problems with it together, it's more than enough. For chapter 6, you are responsible of, if I give you a manometer, a vernier scale, you should be able to read you should know the reading. So you should know how to read a vernier scale, a linear one and a rotary one. And for chapter 7, you are not responsible of problems because already we didn't tackle the problems for it. Okay? So this is in summary what I want to tell you. If you have any question for the exam, I'm ready for it.
Yes.
Yes.
How many questions في بالexam?
There is 36 questions.
Okay. How many of them are solving?
I think I will go back to make sure, but I think 6.
Okay, thank you.
You have, yani between all chapters, you have 2 from chapter 2 from chapter 2, 2 from chapter 3, 2 from chapter 6. I think I will make sure. I will get back to you, but I think it's okay.
Doctor, can you please explain again the question 10 about
Yes.
brittle material?
Yeah. Yes. For question 10, we have seen different behaviors of different materials. Okay. First, what is elastic and perfectly plastic? When we say elastic and perfectly plastic, so if you have like this, for example, if you have, in general, this is the case on the operation on metals at room temperature. So if you have a metal undergoing deformation at room temperature, in general, it will undergo first an elastic zone, and when you will yield, it will yield at a certain point. If you are drawing the log, so if it's a log presentation, okay, then you will have this. You will have here it's like the flow curve. Okay, so this is if you want, this is the behavior of a purely plastic, purely elastic. And here it's elastic and elastic plastic condition, because first you have elastic zone. Okay, then you undergo a plastic deformation that is a normal deformation. So this is called, if you want, the elastic strain hardening behavior. Okay, this is the first possible type. A second type is perfectly plastic. What is perfectly plastic? For example, if you are working at very high temperatures, then what will happen when you go beyond the yield, you will have deformation. And you will have deformation without the need to increase stress. This is called perfectly plastic behavior. And this is the characteristics of materials that are operated above their recrystallization temperature. Okay, so this is called perfectly plastic behavior. On the other hand, for brittle materials will not reach yield point. They will fail before going to the plastic zone. So in this case, you will only have elastic region. This is called perfectly elastic. Okay, so these are the different types you can encounter in behavior of material: strain hardening behavior, perfectly elastic, perfectly plastic. Okay, and
Okay.
each type is, we have seen them in detail in the course material. Okay, so these are the different types. Elastic and perfectly plastic is the case, as we said, of a material that is work at very high temperature, above recrystallization temperature. Elastic and strain hardening is normally the case of metals at room temperatures. Perfectly elastic is the case of brittle materials. Okay?
Okay. وجست one more question لل FCC.
Yes.
It's not four atoms. أنا ما بعرف أنا
No.
عديت إنه at each corner عنا 1 over 8 و at each
لا،
face عنا 1 over 2.
كيف 1 over 8؟ ما أنت عندك atom، يعني أنت عندك an atom at each corner.
بس this atom is not shared by
Yes.
يعني
Okay, it's
all the
shared.
unit cells اللي
Yes,
حواليها.
but here they mean, okay, and if you want to just represent the unit cell, how many atoms are dispersed in it? Okay, so this is what they
آه
mean.
أوكي أوكي
Okay,
أوكي thank you.
other questions? Okay, so good luck for the exam, and please, for all problems in the exam, you should write your solution in detail on the draft. Okay, and at the end of the exam, you take photos of your draft, and please, your draft should be clear, and I want to show, and I want to see the answers in order, because you are not allowed to do backtracking in the exam. So I cannot expect to have disorder in the answers. So please, you should put the answers in the same order of Blackboard. You cannot go back to a question, and the answer in Blackboard should be in agreement with your answer. Please, I don't want to see disagreement. If I have disagreement between Blackboard answer and the draft, it's a zero. So even if you found your error after, you cannot correct it. Or if you want to correct it, you put for me a notice. But in general, I cannot take it into consideration, because the main rule here is to not have backtracking. And don't worry, I will correct. For if you do mistakes in calculation, it's not a problem. I will follow calculation errors. The importance is to not have concept errors. Okay, so don't worry about mistakes due to calculation error. It's fine if you do the right method. You will take a good part of your grade in this. Okay. And for multiple choice, no need to justify on your draft. Just you select the answers, and please read all the possibilities, because you might have several right answers. Any question before we close? And please, I don't want you to scan your exam. Don't tell me I need time for the scan application, or tell us it's scan application. I don't want you to scan. Take photos and send them. I don't want to have late drafts. So when I say at the end of exam time is over, within 1 minute, I want to receive your draft. Okay, I don't want to receive late drafts. And always recheck that you have taken photos of all the problems, because a lot of times after half an hour they send me another problem and I forgot to take a photo. Please don't do this. Okay, pay attention for these things. Okay, and good luck. Yeah, see you tomorrow. And concerning I will proctor you on WebEx. So I will send you tomorrow, I will send you the link for WebEx, for LAU WebEx. You can enter it, and I will monitor you on it. Okay, you should have your camera on. You should show your face and your hands clearly. And I want also, when you take photos of your draft, you should have your ID. So just take a photo of your ID on your draft to know your name. Okay. And at the end, when you send everything, write your name, because when I want to search for your copies, it will help me to track your copy. Yeah, let's see you tomorrow. Bye bye.